last time we were talking about Yang. I hope you remember everything. Any questions about Yang? Remember Yang? Or how was the weekend? I hope you watched the recordings. So, when we were talking about Yang, of course, with the data in the end we can generate or we can validate with the Yang model, we need to do something. So we would want to use protocol like NetConf, RESTconf, gRPC with gNMI, for example, to communicate with the network device and configure it. Because what we saw before was the legacy world with CLI commands using changer templates or Ansible modules to configure the devices. And you have seen this is kind of a tedious work. It's not always fun, a lot of issues, and yeah, there was the need for a better way to deal with network configuration, also for dealing with operational state, because SNMP is also not really fun to work with. And the thing that came up in the end was NetConf and Yang. So if you remember this graph, we have Yang down as the model language who just describes how the data has to look like, similar to JSON schema for REST APIs, for example. And then we have protocols. We could use SSH or HTTP. We could actually use any transport layer, but these are the ones mainly used. And for the encoding, normally what we see is XML, JSON, and GPB. Yeah, just how it's encoded, how efficient it has to be, especially if we want to do streaming telemetry afterwards and get a lot of data from the device. It's good to have some, how can I say, not too verbose data formats or encodings. So, yeah, protocols, what we will see is NetConf, RESTconf, and gRPC. And of course, in the end, what we need to do, if we want to use them, we want to have some kind of applications. Maybe we have an application, there are some solutions out there as well. But yeah, we want to understand how can we send data to a network device. In this lecture, how can we configure a device and also get a decent error message back if something fails. So learning objectives, we still need to understand Yang, that's the same as last week, but now we also want to have the fundamental concept from NetConf, RESTconf, and gRPC. But in the end, there are just 3 protocols we can use to send and receive the data. This is a recap from Yang last time, so the data modeling language, yeah, as I said, it is not a perfect solution in my opinion, but it's still way better than having nothing. So at least we have now a way to describe how the data has to look. It is a kind of complex language. In my opinion, they made it a little too complex, but yeah, if I have a lot of people talking together and everyone wants to have his special features there as well, it gets fast way too complicated. And yeah, if we want to analyze this, we most likely would use some tools. We can have them online, like the Yang catalog, or then we can use, for example, this Python tool, pyGNMI, where we can visualize the whole Yang in a nice tree structure, for example, so that we can also read it easier. Because if we want to go through all the files, and one of the things with Yang is that many things can be in many different files. There can be deviation files changing the standard files, and this gets a nightmare if you want to do it by hand. So we use tools like pyGNMI to analyze our data structure. I hope you did the exercise from last week, maybe. So then you have already used this tool. So this is the standard IETF interface model, for example, we have the container interfaces, and then we have a list of interfaces. Each one needs a name. This is the key here. It needs to be unique. And we can have description type enabled or not, link up down trap enabled. This configuration can also be set. And the read write tells us this is a configuration leaf, and with the read only we would only see this operational state. So we can see which data can be changed, which is configurable, and which one are static, given by the device. As an example, the OS version we probably cannot configure, because this is depending on the OS version that is installed. Any questions so far? Oh, recap from last week. Another example here, they can get kind of big, especially if you, for example, then work with the Cisco native model for our labs. In the native model, it's kind of everything that you can also configure in the CLI, and they can get huge. So one of the important thing, in my opinion, is this tree depth, how deep we want to go with the visualization, and everything down is then just summarized. And then we can use the path statement to say, I want now to this path, and I want to see a little more detail. Oh, that's one of the ways how I normally work with pyGNMI and the models, to analyze which data type, for example, is there, what is optional, what do I have to configure, all this information. But in the end, yeah, you have to get hands-on, you have to use it, because otherwise I can talk here for hours and you will not memorize it after the beer. One feature that also is handy sometimes, we can use another format with -f, and we can say we want to generate the sample XML skeleton, so that here we already see how this XML should look if we send it. Depending on the model, this does not always work so nice and well, but at least we can give it a try. We can see how it looks. Most of the times with the standard models it works pretty well. Then we just need to know what kind of data we have to now put here in the name. For example, this must be a string. Yeah, so we need still going back here and see what kind of types do we have. We have a string, we have an identity ref, so this is a reference to an identity who is existing, and we have a boolean, so true or false for enabled, for example. And if we craft then this XML, we fill this out, we can send this to a device and it will give us a reply if it worked or not. And for sending this, we will have netconf, RESTconf, or gRPC. So netconf is the oldest version, or the first version I would say we used. Here we can see again, we can have any transport protocol, and then everything here with netconf and also with gRPC is RPC based. So if you have used RPC APIs, we craft RPCs. We have different RPCs, we can say. We have RPC with the operation get config, edit config, and we get an RPC reply, hopefully. There would be an RPC error, or there is also an RPC OK. So this is how the protocol works, and one of the good things is that we always get feedback. So if you had the fun with classical configuration, it can happen that you don't catch the error message. The console would reply, but just somehow it's not catched, or not, yeah, how can I say, it's not handled correctly in a Python code, in Ansible or in your own Python code, depending how you do it, and you will not realize that this is not configured how you want. And now here we have a structured way, we will get a feedback, and we can most certainly be sure that it worked. So much nicer to work with it in a programmatic way. Yeah, course, the content is then our data who is validated against the Yang model, so that we can already validate data before we send it, and we know how the data is expected. We also know if we make if we want to get some data, in which format it will come. For that we need then the Yang models. NetConf itself, first RFC was 4741, kind of old. It is replaced or obsoleted. Now we have the 6241. As I mentioned, we have the RPC model with these 4 different type of RPCs, and we have the protocol operations. And the most important thing for me, the whole thing is transaction based. So if I have a configuration of 200 lines and the last line fails, it will not apply any of these 200 lines. Depending on your operation system or in your vendor, you will have that if you work with classical CLI who directly works in the running config, it will be applied. And if there is a mistake, you would need to have your own logic to fall back or to roll back. Some vendors, they definitely provide on their OS features for this, where you can commit the change afterwards and see if it works or not. NetConf brings this standard. We have also capabilities where we can see which device supports which capabilities, but the transaction-based one is definitely something everyone has and we need. The best is just to go to the RFC, so you can read it and memorize everything. Now, yeah, this is the new one, 6241. We can see here obsoletes the 4741. We have some updates. This one is extensions, and this one registration policy update. But the main one we have here is this one, and we are focusing on this one as well. Yeah. So just some text, and here we see, for example, the RPC model. We go here. You can see we have XML in NetConf. We only have XML as a possible format. When we're using RESTconf, we normally can say if we want to have the reply in XML or in JSON. There the arrow code will not be in the, how can I say, there we have the HTTP arrow codes, who also will indicate what state was the call. Here we have these RPCs. So normally we send an RPC in this way here with some operations, for example edit config, and then we will get a reply somewhere. This is just a get, and the reply will then here bring the data, for example. So we have a structured way how this message has to look, or how the XML has to look, with all the namespaces and all the nice stuff in XML we love so much with the namespaces. Yeah, that's just how it was designed, how we have to deal with it. If we go up again, we have then the protocol operations. So the standard operations we can do is a get, to get the information from a model. Can be operational data mainly. We can have get config if we only want to have configurational. We can edit config. We can copy config if we have different data stores. So normally we have a candidate store. We can send our change in the candidate store, and if we get a reply that it works, we validate it, for example, then we can apply it, commit it. We have delete config if you want to delete, and also really nice is the lock and unlock, so we can lock the device that no one else can make changes at the same time, or almost at the same time. So if we want to lock in for example, and we need to read some information first, and then we want to process them, and we want to change something, we can lock the device that no one else can make changes at this time. Because otherwise, if you have some logic where you want to see which devices are there, it could be that at the fact that when you want to configure it, it was already changed by another system. So that's also nice to have, and I really would suggest to use this feature. Or you can close the session, we can also kill the session if we need to. You can see here all the details. I will not bother you too much with all the details, because in the end you just need to use it, you need to have some hands-on. Any questions so far? You like this approach better than CLI? You wish you would have known this before, so you could use it in the lab 1? One thing is definitely also the capabilities here. So if they have the commit capability, if we have the candidate store capability. So in NetConf, if we would make a connection to the network service, NetConf service, we will get a huge list of all the models it supports with all the capabilities. So the device itself will tell us, I support the candidate store, I support the IETF model for interfaces in version X. So this is kind of a handshake we have in the beginning, because we send back our capabilities, and therefore we know what kind of models are supported, what kind of features are supported by this device. So we can also change our logic, our script, depending on what capabilities are there. If we have the validate capability, we want to use the validate maybe. If there is this capability not, we probably want to get out of gears, buy new stuff, because that's kind of handy to have the validate and the candidate store. On Cisco, for example, maybe also important to know, there is 2 implementation of the NetConf. The old one we would reach on port 22, the SSH port, but the real NetConf yang configuration or implementation we want to use is on port 830. So never use NetConf on the SSH port. Always use, when you're working with Cisco, the 830 port, because otherwise you have an old implementation who is buggy and painful. So if you need any details, I recommend going to the RFC, looking at the details there, or just try it out, have some hands-on. You can make SSH to a device with -P830, and you will get the whole capability list. But of course, in the lab, for example, you need to configure netconf -yang so that this service is available. In this model, we are kind of focusing on Python libraries, because you have already the basic Python module, you have Python knowledge, and if I would jump between Python and Go, for example, it would get a little more messy. So we are looking at Python libraries who can help with this, especially if you are in the Go ecosystem. You probably want to go with gRPC and with the Go libraries available for there. But we here we're focusing on the Python world. The most common is probably the ncclient. It is in the beginning a little, how can I say, you have to get the feeling. The documentation is not extremely rich on information how to deal with it, and it also has some magic stuff there that you have functions who are not completely implemented directly, but by accessing this function, the right RPC will be configured. So this is something you have to get used to it, maybe see at the examples. That's also the reason why I have here a couple of examples how we could use this library. So if we want to get configuration from a network device with netconf, and we are using ncclient, we would import the manager. This is the object helper who will make the connection. One thing I highly recommend is always using the context manager with the with, because then the open and the close statement are implicit, done by the Python. As soon as we enter here, the open statement on this object M will be called, and as soon as we exit this with down here, the close function will be called. And then we can make a get config. So with m.getConfig, the RPC with getConfig is generated automatically and sent. We can also craft our own RPCs if we want, but normally we use the standard RPCs, so they're all available with this method. And we can say, I want to get the config from the running data store or from the candidate data store. And what we will get is the response, who of course includes the data with all the XML. If we want to visualize this, we have also a helper to get it into a nice looking XML, because otherwise it's just a huge blob of data. And yeah, we can access the whole XML here and pretty print it. And for example, with this you would get the whole running configuration from a Cisco device in XML. It's similar like if you would go to a Cisco device, a newer version, and you would make a show running config and then pipe format netconf minus yang, I believe. And then you also get the whole XML. And because this is structured, we don't have to parse anything, so we can use XML tools to access the data we need to, and to change it and send it back, for example. Yeah. Many times there would be huge if we just would get everything. So what we can do, we can also use filters. We have two options for filters in netconf. We have subtree or we have XPath. You can read both in the standard RFC. What is the difference from the XPath or from the subtree? And now we would, from the native model, only get everything inside of interfaces. So if we want to have the running config but only the interfaces, this would be the way that we don't get too much information from the device. Because depending on the device, if it's in production, the running config can get huge, especially if you have a lot of access control or BGP policies or prefix lists, everything. So here we can already filter and just tell the device, hey, give me everything from native interfaces, and that's enough. Or if you want to use another model, you can say, give me everything from OpenConfig, network instances, and then you will get everything only from this model there. Yeah. So just here in the get here, normally we would get a lot of information. We can use this filter with a tuple, subtree or XPath, and then the filter itself here to minimize the data. This is the option with XPath. So just another way to describe which data we want to have. XPath, kind of complex way to describe something, because we can also use variables. So if we are dealing with lists where we have a lot in XML, we can say I want everything in the list of interfaces who has the name starting with gigabit, for example. Something like this we can do with XPath. And yeah, besides of that would be the same output like we had before. Just another way how we can do it with the filter. As I mentioned, we have the lock, so pretty handy to send this RPC directly. We don't really have to care about how the RPC has to look, because ncclient, the library, will deal with this for us. We can use lock or unlock. If we really want to do it by ourselves, and of course we have to say which data store we want to lock. We can also lock multiple ones, but then we have to unlock multiple ones as well, of course. And also for me, the recommended way would be again to use the context manager with, because here, if we use locked, the lock and unlock will be automatically called again. And yeah, we will not forget to unlock the data store. Yes. Exactly. If it goes out of the with, it will unlock it. So if we go into the with in the context manager, it will automatically lock the running in our example. If we go out, it will automatically unlock it. It's the same like if you use the with, the context manager, for writing files, for example, in Python. If I open a file with the with statement, it is automatically opened with the permissions I defined. And if we are finished with the with block, it will automatically closed. So we don't have to handle the open and close. It's also for the manager here. If you remember, when we were looking at NetMiko and Napalm, they also use the config manager that you open and close the connection automatically. Yeah. And in my opinion, it looks much cleaner if you know this feature. Because otherwise you have always these two statements and you have to say, here I open, here I close. Here it's everything automatically. So this would be the Pythonic way to do it. Of course, we want to edit some names. So this is a simple example how we can change the banner. If we log into a device, we normally see the login banner who tells us that I'm only allowed to log in if I'm permitted to it. So that if I would log into a device, I have no business with it, that this would be not so nice from my side. So in this login banner, of course, we can also change it for the execution banner, for example. And here we defined in the configuration, in the native model, banner execute, the banner want to be this string. And if I send this with the edit config RPC, in this case directly to the running context, if I, for example, for Cisco don't have enabled the candidate store, this will be applied immediately. And then I have the login banner. And if it will be an issue, an error, of course we will get a nice error message. Nice. Yeah, it's not always nice, the error message, but definitely there will be an error message. So that is already nice, because we can see, did it work or did it not work? Yeah, and this is an extremely simple example. I can change all the configurations like this, and I can even change multiple things in the same RPC. So I can here change the banner, but I could also change it, the same request. For example, the, how can I say? The BGP peering for a specific address family. I could also change it at the same time, and the banner would only be changed if the BGP peering update would also be changed. That is one big difference between, what can I say? Between NetConf and RESTconf. RESTconf, with the REST concept in mind, we normally just have one path, we exit this, and we can replace, or we can update, or we can merge. Here we have more flexibility to do more stuff in the same call. We can add some stuff. We can also, you have operation defined here with the namespace as an attribute to say this here I want to delete. So I could also delete something in the same configuration XML and add something else. And with NetConf, the only thing I could do, NetConf with RESTconf, would be to go to the top level of all the where all the changes are down, and then, for example, replace or merge the whole thing. So it's a little more, how can I say? Normally, if we use RESTconf, we have multiple API calls, and here we normally have bigger XMLs with multiple purposes in the same one. So we can here really take advantage of the transaction-based configuration. Does this make sense? Yeah, here is already the delete option. This is also depending a little on the device, on the version. So you have to look in the documentation of the device. Sometimes you have to specify the namespace as well so that it works. But we can delete here the banner we configured again with the edit config, with this operation state or attribute, I have to say, in XML. Yeah. So ncclient is used in many libraries as the backend library. It's a pretty simple library if you look at the code in the end, but the documentation is maybe not the best, could be improved. Yeah, you have to try it out, you have to use it to get the feeling for it. Another option in Python would be scrapli. If you remember, this is an alternative to NetMiko, but scrapli has also a driver, a device driver for netconf, so we could use it as well. It is similar to the other drivers for the CLI from the feeling here, from the feeling we have, and one of the big differences is scrapli would support async and synchronous Python code. So if we want to have, for example, async Python scripts, we would go with scrapli, because there we have async support for our netconf implementation. Also, the documentation, in my opinion, is much better than the ncclient. If we open, I think, user guide, for example, quick start, yeah, you can see basic example. Just print out the result, for example. We see here then the data we got, but we can also have then different examples. Edit config on a XR, for example. Okay, now we are in GitHub, but yeah, you can see how this would work. You can have some examples. Advanced usage is always interesting. But in the end, we have two libraries with similar capabilities. One of the big differences is definitely the async support for scrapli. So to get config for from scrapli, we would just create this object netconf driver with all the data we need, and then also with context manager again, we would make a get config running. So this looks pretty similar to the ncclient, but in the background the implementation is definitely different. Yeah, but we can here get the get config, but of course we can also edit config, the same example. Sorry. What we always have to check if we use different libraries, what kind of data do we need? So here, for example, I have to specify the config level. If we go back, edit config, we also specified it here, but I have seen sometimes differences between which library. If you have to specify for the edit config the first level config or not, it always depends on the library. So always look at the documentation, what exactly is needed. But in this case it is the same, the namespace again, and then we can set the banner. and here we have the lock and the unlock, for example. Yeah, we would need to see in the configuration and in the documentation if there is a context manager for lock and unlock. I'm not sure at the moment. It's also something we always have to see, which library do we use, which capability does it has. Yeah. Then if we're dealing with XML itself, of course, I'm personally not a huge fan of XML because it's, yeah, I'm not so used to working with XML than I'm used with JSON, because JSON is closer to the Python object like dictionary and list. Therefore, I personally prefer to work with JSON if I can choose. But with XML, of course, we have a lot of support. We can have this XML library to work with the XML3, all the fun stuff. And there is also one library who is worth mentioning, is the XML2dict. So this converts an XML and generates us a dictionary or Python object. Sometimes with namespaces it can be a little painful to work if we have a lot of namespaces, all the stuff. So there's also a way to, if you just want to get the data, to remove all the namespace information, then it's easier to work with it later on. But it's also a library that you is handy to know that this exists. You have to try it out, you have to play with it, you have to get your hands dirty. Yeah. So what I added now here also is the pyGNMI. So this would be a Python library that we can work with gNMI, who in the end is nothing else than using gRPC with the network management interface. So we can work, or we can use in Python the gNMI protocol. So not netconf, not RESTconf. So the next option would be to have this. Especially if you, for example, are in the microservice area and you're developing a lot of microservices, you probably have some hands-on with gRPCs, communicating between your services. And yeah, now we can also use gRPC for the network devices. But this is also something the device has to support, of course, and you have to enable. It's kind of simple what we have in Python enabled. So we have the capabilities. We can query what are the capabilities of the device, and we can get or we can set information. And also interesting, we did not talk a lot about this so far because we have another lecture on streaming telemetry where we use NetConf, for example, for getting streams of data for the operations. For example, if we want to analyze the network traffic or the counters on interfaces, all this stuff, we can use NetConf to subscribe somewhere and get information as a stream. The same we can do with gRPC, with the gNMI. Yeah, this would be an example how it looks. We have the gNMI client. We can define which paths we want to get. So here we can get multiple paths at the same time, and we can make a get or we can make a set. And the encoding, we can have JSON to have nice JSON, but of course, if we saw in the first slide, we can also have binary encoded data encoding for reducing the bandwidth usage. So that's one of the advantage of gNMI. There is now at the moment the RFC going on for NetConf, that for streaming telemetry for Yang push we can use CBOR that's going in the same direction, that we can have binary encoded data, just because of too many data coming from XML, because it's kind of a verbose language. Yeah. Any questions so far? How do you like this approach? How do you like XML? Who is XML fan? Not so much. Who is JSON fan? Yes. We are definitely more used to JSON, because if all the APIs we normally are dealing with, we have JSON. So these days, in my opinion, JSON is definitely easier to deal with. We also have more tools. It's closer to the Python data structure itself. But yeah, XML also has their advantages, especially if we would use these features with XPath and all this stuff. Yeah, normally what I would do is convert the XML in the data structure I need to read all the data. Then I have the Pythonic way to deal with my data, and in the end, if I want to communicate with the device again, if I'm using NetConf, I need a way to generate this XML. So how would you normally generate XML? Most likely your first thoughts would be, I need a XML library where I can define how my XML has to look in a programmatic way, right? I have to specify, I have to loop over, I have to build my DOM, right? The whole tree with all the information. That's definitely the way we should deal with XML. Sadly, the reality in network automation is that many times we are maybe too lazy, or it is just too simple to use stuff we already know and not invest more time to make it the real way. I have seen way too many times that we use Jinja to generate XML, so that we treat the XML, who is a structured data form, we can craft from objects, we can craft in a programmatic way. We use a text template language, and it is just sometimes complicated and tedious work to do the XML, who is kind of big in a programmatic way, in a also testable way. So yeah, many times we sadly craft XML with Jinja. I'm still looking for the perfect solution how we can avoid this, because many times I have seen it. I have to confess, many times I've also done it, because it's just faster. Because if I just need to replace some values, I can have the whole XML replace the values. Yes, I can do it with Python directly. It would be much nicer. But if we anyway have to deal with network configuration in a traditional templating way, it is extremely tempting to just do it with XML. Officially, I have to say, please don't do it. On the other side, yeah, I also do it sometimes, depending on the project. So yeah, maybe in the future we have a better way. Definitely much easier if we deal with JSON, right? Because it's closer to the Python world. We are more used to it. That's probably the most important thing, because if we would deal every day with XML APIs, it would be also easy for us. But yeah, I hope it was interesting, but in the end you have to really try this out. You have to use it a couple of times to really get the hands on this whole thing with the Yang model. How do I get the data structure? How do I ensure that I'm sending the right data? Many times we make it easy and we get some information, we adapt it and we send it back. That's also a way to do it. in the end you have to find the way how you work the best with NetConf and with Yang. Thank you very much. Any questions? Thank you.